All right, so it says, warm up. The number of text messages teens send and receive every day can represent a normal distribution with a mean of 100 text messages per day and a deviation of 25 texts per day. Who thinks that they send 100 or more texts a day? 100 or less? Think less than 100? That's good. So we got a couple that are all the way over to the right. Okay, so we're going to draw that curve. I'm missing my pen, so mine's not beautiful. My pen's like a little guy here. What number goes right in the middle? 100, because it's the mean. How do I get in purple to the right? How do I get add 25? So I get 125, then and beautiful. Now in orange, I'm going to work backwards. You always go 3 above and 3 below. So how would I get to the next one? 75, 50, and 25. All we're doing is subtracting 25 this way and adding 25 this way. That's all that question was asking. It was not asking you to do anything else. Questions on that one? All right, it says, 2, according to the distribution, what percent of teen population sends more than 125? So this might be Naki. He sends more than 125 a day. So I'm going to put my little tick mark at 125, and I'm going to shade it. Is it going to be below or above it? Above, because I want more than. So I'm going to go to the right. Well, because we have our awesome graph drawn out, and we have our deviation set, we can just use the empirical rule. So you guys have the empirical rule on that green sheet. Whenever you're looking for a percent, when you're given the deviation, it's on your graph, you can just go right to that empirical rule. So I'm just going to write out ER so that you know that's what we're using, the empirical rule. What percent is this guy right here? 0.5. What about this one? And then 0.15. Again, the more you write it and the more you use it, you're going to memorize them, because then this whole side is the same. It's symmetric. So what are we going to do with all of those numbers to find the total percent? Add them. So I have 13.5 plus 2.35% plus 0.15. And let me know what you guys get. What'd you get? 60 what? Just 16%? Okay. Good. Any questions on that part? Because that's a warm-up. That's something from way back last week, the empirical rule. Okay. What is the z-score of 130 text messages? Does anyone remember the z-score formula without looking?
It is z equals x over whatever,
What's this called? The mean. Yes. Very good. Okay, so as long as you have some sense, because you're given the formula, it's on that green sheet. So we're going to go ahead and plug it in. It just wants the z-score. So if I ask you for the z-score, you don't have to go inside that table like we did. It just wants the z-score. So I have 130 minus our mean of 125 all over our deviation, which was 25. Just make sure you're putting that in parentheses. And let me know what you get.
I thought it was 100.
Is it 100? Thank you. It is 100. Our mean's 100.
Wait, what?
Hold on. Sorry, our mean is 100 right here. I messed that up. Our mean at the top is 100. 1.2? It just wants the z-score, so we're done. It didn't want the percent. It wanted the z-score. Okay, do it for 48. Do that one on your own. Do that one on your own. Give it a try. What did you guys get?
Negative 2.0.
Negative 2.2. That's a 2.
I have negative 3.08.
Let's see. Parentheses. 48 minus 100. Close it up. All divided by 25. And I get negative 2.08. So be careful. Make sure you're putting those parentheses in the calculator. You can also do it where you do 48 minus 100, press enter, then divide if you don't want to put in parentheses. Do you have questions on just finding the z-score? So that's all like review from last week. Okay. What percent of teens population sends between 48 and 130 text messages? So when you do between, remember, find it, find the percent, then you're going to find this percent, and what am I going to do with them?
Combine them?
Not combine them, it's like the opposite.
Oh, subtract.
Subtract them. Whenever you see between, I want you to think that you have to subtract the results. Whatever you get, you subtract at the end. So the cool part is we've already prepped for this. I know the z-score of 48. It's this. So look that up in your chart. So let's look up negative 2.08 in our chart. So I'm going to get out my z-score chart, and I'm going to look up negative 2.08. So make sure you're on that negative side. So I have negative 2.0 on the left side here in yellow, negative 2.0. And on the top, I have to find 8. So in blue, here it is. What was that percent? Good, 1.88. When you make that a percent, it's going to be 1.88. So the z-score for 48 is 1.88. Is that what we said? Okay, now let's do 130. Look, we already found the z-score for 130. It was 1.2. So let's go in the chart and do the same thing. So go to 1.2, but now we got to go back to the positive side. 1.20. So 1.2 here in yellow. Then we have 0 in green. What?
8 for the
Good. You guys are doing good at this. You guys are going to do good on this test. So I have, what was it again?
8.1.
Go ahead and subtract them because I told you that whatever the percents are, you subtract them. And what do you get?
56.61%.
Good. So let me explain what that means. So from all the teens, you guys are all teens, even though some of you are, I don't know, is anyone 18 in here? Well, that's still teen, I guess. But if you are a teenager, they did a study, if you, 86% of teenagers send between 48 to 130. I would say that's normal, 148 to 130. I would say about majority of our teens do that, and that's why it's 86%. Okay? We're just going to go, we're not going to do the challenge. I want to keep going. Make sure we have enough time. So go ahead and flip when you're ready. Flip when you're ready. Okay, what is a percentile? For example, what does it mean when you say your ACT score is in the 80th percentile? Anyone know? Because when you get the ACT or the SAT, they're going to be like, okay, you're in the 50th percentile. You're in the 6th percentile. Do you remember seeing that?
Like a placement?
It is kind of like a placement. But what does it like mean? Kind of your level. So it means that the 80th percentile, that means that 80% of people scored less than you. Okay, if you're in the 80th percentile. If you're in the 90th percentile, that means 90% of people that took the test that day scored lower than you. So if you got a 30 percentile, that means that 30% of students that took it that day scored less than you. That's what it means by percentile. So you're kind of comparing, when you get those scores in the SAT, it's comparing you to your peers. Okay, does that make sense? All right, so now we're going to kind of do the reverse. So we're going to take it slow here because this one's probably the most challenging, and then we're pretty much did everything that we need to. The number of text messages teens send and receive a day in a normal distribution is 100. So we're doing the same exact problem with a deviation of 25. Calculate the 50th percentile for this data set. Explain your reasoning. Okay, so 50th percentile. How do I write that as a percent? 5.0 would be 5%. 0.50, very good. So you always want to convert that to a decimal. So 50th percentile. Now, we still know our mean. Our mean is 100, and our deviation is 25. So we basically have almost everything, but we don't know the score. Okay, we don't know the score for the SAT, so we're going to kind of set it up in a different way. So remember, our formula is x minus our mean all over our deviation. Well, we still have our mean, we still have our deviation. We can find our z-score, and we can figure out what that test score has to be in order to be in the 50th percentile. I'm going to show you how to do that. So you really need to have that green sheet out, the z-score table, so you're doing it with me, because this is probably the hardest part. So, that dark green sheet, please have it out. We're going to be looking for 0.50, not outside anymore. You're going inside the table. So let's get that out, and I'm going to show you what I mean by that. So inside the table, if you look, here's the outside. This is the inside. Whenever you're given percentile, you're looking inside, because these are the percents. Remember when I asked you in the last question, what was a percent? Percentile, think inside. So let's look for one that's really close to 0.50 or is 0.50. Do you see it?
Yeah.
It's right here, right? Well, what's that z-score? 0. Okay, so we're going to take that 0 and we're going to put it into the problem. So let's see. So we know our z-score. Our z is going to be 0 based off of what we just saw. We're going to plug it in. So I have 0 equals, we don't know x, minus our mean, 100, all over our deviation. This it's why we do that solving unit in the beginning. So this is a two-step problem. How do I get rid of the 25 on both sides? I multiply them. Very good. So I'm going to multiply by 25. That's gone. Well, what's 0 times anything? 0. So I get 0 equals x minus 100. Well, now what do I do to both sides? Add 100. So x is 100. I wanted to prove that to you. So think about what that means, though. Let's see if this makes sense to you now. Looking at your curve that we drew earlier today, when I scroll up. Oop, this was supposed to all be here still. Okay. Think 50% of your graph is located right here. Didn't we just prove that? 100? Okay, 50% of the graph is right here at 100. So we just proved why that works out that way. Okay, so it's pretty cool. So let's do another problem. Just like that. So would a teen in the 90th percentile send and receive more or fewer than 100 text messages a day? So would a teen in the 90th percentile, so it's all the way to the right, would that score be more or fewer than 100? What do you think? So let's look at our graph really quick. Yes, it would be more. So look, this whole entire graph, think of it as like the empirical rule we were doing in the beginning. This is half of our graph right here, yes? Right here, 50% is right here. That's what the mean is. Well, if it's 90%, it's got to be somewhere over here, so it's got to be above. So just trying to get you to read those graphs a little bit better. So this one's going to be above. So above the mean. So we are going to have more text messages. Questions on that? Again, when you look at that graph, the mean is always the middle. That's 50% of your data. Well, if it's 90%, it's got to be more to the right, so it's more. Now think about this one. What about 10%? Think 50% in the middle. Would 10 be this way or this way? To the left. So is that going to be fewer text messages or more text messages? Fewer. So just getting you to really think outside the box right now. And again, I'm just going to kind of draw this little graph so you can see what I mean by that. 10th percent would be somewhere like right here. This would be like the 10th percentile. And then the 90th percentile would be somewhere about right here. Just kind of so you're picturing what I'm seeing when I'm trying to describe this to you. When I'm talking about 10th, we know it has to be lower. We're talking about 90th, we know it has to be higher. Questions? Really analyzing those graphs. Okay, now we're going to actually do the problem like we did above. Use a Z-score table to determine the 90th percentile. So, how many teens, we want to figure out how many teens or how many text messages does someone have to send in order to be in the 90th percentile? So, same exact problem. We know the mean. What's the mean?
105.
What was it? 100. And the deviation is 25. We don't know Z and we don't know X, so we have to find them. So, in our formula, we have this. I want to keep writing it out because the more you write, the better it is. All right, so again, we know the mean, we know the deviation. We need to find the Z before we do anything. How do I write 90% as a decimal? Good. So I'm going to go off to the side here. I'm going to have 0.90. Whenever you see percentile, you're thinking inside the table. So here we go. Go to your Z-score. You're looking inside. Here it is, all this inside stuff. Try to find the closest one. It doesn't have to be perfect, but find the closest one to 0.90 inside the graph. Let's see. 1.30 would be like right here. Yeah, that one looks close. What do you guys think? Yeah, I'll accept that one. Is there anything closer to 0.90? Isn't 0.9015 a little closer? It is. I would not dock you, but just know that your answers on a multiple choice might be a little off if you don't go closer. So really, technically, this guy is a little bit closer. But when you think about it, isn't this one closer?
Yeah.
Yes, because it's only 0.0003 away. Again, if you would have chose any three of those, I would have been happy. Okay? You'll still get pretty much the same answer as me. It's just going to be a little off. So really, this guy is our closest one. So what's the Z-score? So let's go to the left. It's 1.2 what? Good. 1.28. So we're going to go back to our notes. And we found out that our Z-score is 1.28. Now we can do what we did earlier and find how many text messages do you have to send in order to be in the 90th percentile. So let's go ahead and solve it. I have 1.28. We don't know X. Whenever you're doing percentile, you're going to be solving for X. Minus our mean all over our deviation. It's good. The cool thing about this is it's the same thing over and over again. You're really not doing anything different. What do I got to do to both sides to get rid of the 25? Good. It's already dividing, so I'm going to multiply. Gone. What is 25 times 1.28?
32.
It is. Very good. So I get 32 equals X minus 100. What's my last and final step here? At 100.
132.
Good. Can anyone, for a prize, try to explain to me what 132 means in this situation? Did you say yeah? No? Does anyone know what we just found? Kind of talked about it a little bit. We are in the percentile, but what is 132? Yes. So the number of text messages that you have to send as a teenager for you to be in the 90th percentile. That means if I send 132 text messages a day, 90% of students or teenagers text less than me. Okay? So that's what that means. It's what you just found out. Okay? Good. Refill this. I got lollipops, I got Smarties, and I have Starburst. That was a good. If you are able to comprehend what we're doing, that means that you truly understand it. So make sure you open in that mind. We had some good answers though. Okay. Well, we already did that. So A and B, we've already done. That's like the same. We kind of did it all in one. So go ahead and flip. We're just going to keep doing problems together. So it says, number 1, calculate each percentile using the z-score table of the heights of women that are normally distributed with a mean of 64. Our mean is 64. And our deviation is 2.7. I always write out everything. Okay, I know I'm going to need my z-score, and I know I'm going to need my x, because those are everything in my formula. I write my formula so many times that I don't even forget it. So z equals x minus mu all over our deviation. Same thing again, nothing has changed. We're doing the same problem over and over. Now, I see I want the 10th percentile for women's height. So first I ask myself, how do I write 10 as a decimal for percent? Good. So I now must go inside the chart and find the closest number to 0.10. So here we go. In that green. Got to practice this because this is tough. And if you're not trying it right now, it's going to be a struggle later on. If you look on this whole entire first side that we were earlier, I don't even see 0.1 anywhere. So flip it. It's going to be somewhere on this side. On the negative side. So try to find the closest number to 0.1. 0.1. So I'm looking, I'm skimming, nothing. I'm not finding anything. Good. 0.1003 right here. Do you see that? That is the closest one to 0.10. Questions? So, can someone tell me the z-score? What'd you say? Negative 1.28. Good. So negative 1.28. Good.
Do I need to get rid of negative though?
Nope, we always keep the negative for the z-score. You get rid of the negative when you're finding the percent. When you're actually talking about a z-score, that can be negative. Well, look, now we have everything. We don't know x. That's what we're trying to find. So I'm going to plug it all in. Negative 1.28. We don't know x, so leave it alone. Minus 64, because that's my mean, all over our deviation of 2.7. Go ahead and take a second and solve it on your own, because I know you can. If you need more room, I'm going to cross this one out so you can write bigger. So you're trying this problem. How would I solve for x? I'll let you know in 1 second.
I got negative 3. Yeah, that's what I got.
And then plus 64. You should get, yep. So check your work
I
with,
got 57.088.
so be careful, check your answers. Let's look. So the very first step is I multiply both sides by 2.7. When you do that in the calculator, you get negative 3.456. And then you have minus 64. So make sure you're doing the opposites. You have to add 64 to both sides. When you do that, you should get that. Yes?
When I subtract, I got
You're not minusing, you're multiplying. Yeah, you're okay. Any other questions? Good questions. You guys are doing really well with this, and I'm very, very happy. We're almost done, so don't worry. Questions, questions, questions. Can anyone describe what we just found for a prize, other than Nick, since he's already got one? Go for it. Kind of. What does 60.5 mean?
6 foot 5.
Kind of. What does 60 mean in this problem?
Inches is 6.
Okay, good. So 60 inches of women. So what does that mean, though, with the percentile? Hmm?
Like the range.
The range.
That's the average height.
Not the average. We know the average. It's right here.
8.
I'm literally just trying to like pull it out of you. Let's see how it goes. So before, if we look at what we talked about earlier with Nick, when he told us 132 meant that you had to send 132 text messages to be in the 90th percentile. Well, in this situation, we're talking about women's height. How tall a woman is. So you have to be 60 inches tall to be in the 10th percentile of women. So if I do that but divided by 12, we can kind of relate to. So you have to be 5 foot to be in the 10th percentile. That makes sense because 5 foot is kind of short. So you're going to be on that shorter range of the height. So that's what it means. Whenever you're finding this, okay, you have to be 60 inches to be in the 10th percentile of heights. Okay? When you go to the doctors, they tell you. If you ask them, they'll tell you what percentile you're in for your height. They will. For your age. Okay. We're going to do one more and call it a day. We're going to do B. And I want you to cross off this and put top 15. Because there's one like that on your exam. I want to make sure we go over it. So if it asks you, so kind of like more than in the last part when we did it for the warm-up, when Nick asked the question about the homework and it was awesome, it's kind of the same thing. If you're in the top 15%, well, when we look up the z-score, it's only the bottom. What do I have to do with 15 in order to find what's less than it? What? Yes, good. So whenever you see top or more, you have to subtract from 100. So I have 100 minus 15. And what do you get?
85.
It gets 85. Okay? So whenever you see top, put a little star. If you see top or if you see more, you have to subtract from 100. Because remember, if you look at the top of your z-score chart, you see Jalen's here, it's always below. This chart doesn't tell you above. Okay, we don't even have a chart for above. That's why we have to do the 100. Okay? So, same process here. We know our mean. What's our mean? Read the problem. What do you think?
20.9.
Good. So our mean is 20.9. What's our deviation?
4.8.
Good. We need to find the 85th percentile. How do I write that as a decimal? Good. So we got to find the z-score that goes with 0.85. So get out that green sheet and look in the middle for 0.85. Well, on the negative side, it's not going to happen, so let's look at the positive side. We're looking
85.
85, so you're somewhere in this range.
I got 0.04 and 1.0.
Okay, so 1.04 you're saying? Right here?
Yeah.
Yeah. Some people are saying this one in purple. Try to see which one's closer, the green or the purple, to 85. What do you think?
I have negative 2.39.
Negative 2.39 is on the other side. And negative 2.39, you see how that's going to give you 0.84%? It moves it over. Here, this is 85%. So you're looking for 0.85, not 0.0085. Okay? 1.0 what? This one in green or this one in purple?
Anyone in purple?
The one in the purple is closer. It's only 8 away. Again, if you would have chose this one, it's okay. You would have still got it right. But this one actually is closer. This one is 15 away. This one is only 8 away. Okay, so that's totally fine. Either one of you chose would have been the correct answer, trust me. So that z-score is 1.4. So right here in purple, 1.4. 1.04, sorry. 1.04. 1.04. So I have 1.04 equals x minus my mean, which we said was 20.9, all over our deviation. Do this problem, and I'll give you your homework once it's done. I'll come around and check it.